In general, functions will have graphs with several different possible properties. We're interested at the moment in even and odd functions. So an even function is a function that if you plug in negative x, it's like you plugged in positive x. There's no difference. Okay. This graph will be symmetric about the y-axis. Remember, symmetric is if you fold the paper along the y-axis, the two sides would match up. An odd function is if you plug in a negative x, it's like you can pull the negative sign out and put it in front. This graph will be symmetric about the origin. This is a much more harder symmetry to understand. It essentially means if 2 points start at the origin, whatever the point does going up, it does the opposite going down at the same time on the graph. Let's look at two examples and determine if they are even or odd, or possibly neither. To test for either one, we're going to plug in negative x. So everywhere we see an x, we're going to replace it with negative x. Okay. And now we get to clean it up. This first term is a negative 3 times a negative x cubed. So there are in total 4 negative numbers, which create a positive number. This second term is minus 2x. Now, to see if it's even, I now say, is this the same equation as the original? And it's not. So it's not even. To see if it's odd, I say, is this the same as the original, but with all the signs changed? And it is. It is the original equation, just with all the signs changed. This means that the function is odd. Let's test our second example. Again, I'm going to plug in negative x everywhere there's an x. And I'm going to clean it up. The first term, negative x to the 4th power, well, 4 negative numbers together give a positive number. It says negative x squared, which is positive, times negative 3, and then plus 2. And I say, is this the same as the original? And it is, which means that this function is even. If you notice, we now see a pattern. The odd function had all powers of x odd numbers, and the even function had all powers of x even numbers. Now that is not a foolproof method because sometimes you're not going to have things that are just powers of x. But if you happen to have just powers of x, you can just look and say, are they all even? Are they all odd? And it will tell you if the function is even or odd.